OWASP, the Open Web Application Security Project, will have a meeting on August 6th at the new Secure Ideas Training Room on Quarry Road. Yeah, Quarry Road. I don't know. If you're, are you on their Facebook group? No. It's on the website.
I was just standing here because it was convenient.
Yeah.
All right, guys. So,
for the presentation today, I'm going to do a little bit about bash scripting and just kind of show you how different things work inside of bash for building basically programs. It's very useful in building all kinds of stuff. Like you can make programs very easily as opposed to knowing a programming language like Python or C or anything like that. Yes.
I'm sorry, that blue is not working for my eyes.
It's not going to be that way. Okay, that's a little better. This is the, this is a shell script. It's not terribly long. We only have a couple of different functions and stuff in here. But made a little dig on the nav user, especially with them. With this, I've set syntax on, background equals dark, and colo is elf lord. There are, syntax on allows you to have syntax highlighted. BG equals dark is the dark background, so it sets it to where it's a dark background, and then I went ahead and just, there's a whole bunch of different colors you can use in them. So you can do colo and change that. If you do colo and hit enter, it'll show you what you're currently using. Yes?
Even behind the pounds, are those comments out, or is that?
I'll get to it. So your program should generally start with bin bash. You can start it without it, but what bin bash does is it initiates a child shell and then runs everything in that shell, and then once the program is done, that child shell exits, and then you get popped back into your original environment. So generally, and this is for like Python and everything else, this is the interpreter. And so we're just saying my interpreter is bin bash. If I didn't do this, and let's say that my preferred shell was K shell or C shell or C shell or what, you know, there's a whole bunch of shells on this file or on this system, and I ran it with something else, and those things that I was doing in it weren't allowed to be done in those shells, the program would fail because I'm running it as SH, but it has things in it that need to be run as bash. You got to run it as bash, so this prevents any of that kind of thing from happening. So, bash is the born again shell. It's kind of an iteration of shell, so there's original Unix shell, and then other ones came out.
It was the original born shell.
Oh, it was born shell.
And then there was the C shell.
C shell, corn shell.
Corn shell.
Okay. So bash is great. It's been around since I started using Linux back in the 90s. So it's been there for a while. We're just going to do a bit of basic usage, some useful things. A couple of great resources to learn a lot of this stuff is one, this thing has been out since I started using Linux. It's the TLDP project, so the Linux Documentation Project. Fantastic resource. They have all kinds of good information there. If you look up, how do I do this in Linux? It'll probably be like the first or second link on Google, pretty much every time. So tldp.org, great resource. My friends, one of my coworkers just showed me this the other day. There's a site called cheat.sh, and it runs, you can actually curl it as well. So you can actually just curl cheat.sh and then / whatever you're trying to look at, and it's a cheat sheet. So it's a Linux cheat sheet, and it has a whole bunch material in there for this stuff. And then there's a whole bunch of other pages. One that I've always had a lot of good luck with, that I've always had really good information, is Nixcraft, the cybercity.biz. They've been around for a long time, and it's a blog, and he's got good stuff. So anything prefaced except for bin bash, which is interpreted, is a comment for the rest of the line in bash. So if I have a comment, like right here, this is a comment, this is executable code, and then as soon as I have this first hash sign, the rest of that is a comment. So this second hash sign is a comment as well. I like to do two hashes a lot of times just so you can see a little bit better. Now, in a lot of my scripts, we're having, like in my job at least, we have people that run things and they also have root access. And we don't want something to run as root. You would want to prevent the script to be able to be run as root. You would do that with this type of line. Now this is an if statement. The if statement is one of your core components of shell scripting, or well, any program really. You're going to see parallels to different types of programming in everything. So if you look at Python, Perl, C, Java, Bash, whatever, they're all going to have, I know it looks like that, and they're all going to have some kind of aspect that is logic, right? So that's how you build programs, is you build them with logical structures. So this one, I say if, and then I do a test statement. If the UID is equal to 0, then it does this stuff, right? So I say echo, which is send this out to the user. This script must be run as a non-root user. Goodbye. Exit 1. Now an exit in bash, well in Linux, 0 is good. Not 0 is bad. Okay, so if you exit whatever, that's a bad exit. So you can go and you can query that when the program ends and be like, what was the exit? As a programmer, if you're building a shell script like this and you want to say, well, I want to know if it exits like this, or I want to know if it exits like that, you can give it different exit numbers. So I could put like exit 4,000 or exit 52, whatever. And what would happen is when this exits, it will throw that exit code. And then I can look at the exit code on the command line and be like, oh, it threw an exit 53. I go into my program here and I look for exit 53 and it's unique and it's right there. So I know exactly where it failed. I know exactly where it exited the program. So that's some useful knowledge for scripting. So let's go ahead and try to run this as root. What's that?
How do you get the exit code?
Let's take it down.
Okay.
So, $? is the exit code of the previously exited program. So, now that we've passed that, we need to define functions. Now, functions are a fairly advanced part of bash scripting. You can make a bash script without functions, no problem. Any one of these bits, you can make a bash. Like running shebang bit bash. That, by the way, the hash and the $sign is shebang. That's what everybody calls it. What's that? Okay. But it's shebang bit bash. That is up at the top, and then here we have the functions. Functions allow you to break your program up and reuse pieces of code over and over and over. So let's say that I have a menu, right? I want to run that menu, but I don't want to have it 40 times in the code, because one, not only would I have to have the code be 40 times larger, and not only would I have to paste it 40 times. But if I ever wanted to change anything, ever, I'd have to do it 40 times. All right, and that leads to human error is the #1 cause of problems in systems, period. Because, I mean, systems are made out of silicon and run on electricity. What are most problems? Code problems. Okay, that's what's going to get. So you want to make this robust, you want to put in your comments, you want to see what's going on. All right, so this function, which freaking does, scratch this. See the whole thing. All right, this function is the menu. So I say function menu, all right, that builds a function named menu. Whenever I want to call it, it's called menu. And we'll see how to do that later. I run clear. Now these are all just commands you run on the shell, right? So you just run on the shell. There it goes, So clears the screen. Echo, welcome to JaxLUG Presentation. Your options follow. I see a select. Select is a special way of building a menuing system. It's very simple to do, but you can do it in different ways. There's all 100 ways to do anything, which makes it both frustrating to learn, but really easy once you understand how it's going. And that's like, oh, I want to do it this way, I don't want to do it that way. All right, so select action. Action here, I tried to make sure that all my variables are capped. So action is a variable. You don't have to have it capitalized, you can have whatever. But action in do, tux, expansion, arrays, exit. Do, echo, nothing, which just gives me a new line. Your choice, colon, action, echo, new line, break. What's going to happen is select is going to sit and wait for the user's input. It'll be like, it'll go a little menu, it'll say like 1 through 5. And it says, what do you want to do? Do you want to do this one or that one or that one or that one or that one? And then when you hit it, it'll say, okay, you want it to do, and it puts that word here, right? Because this select moves this word into this variable. Then, once this menu is done, we have this section. Now, this is what actually runs the other functions, okay? So I say if, or our if, test, which is the square bracket, the value of action equals the value of do. Now, I did this a couple of different ways to show you guys the differences here. Action, single equals, quote, do, quote, because you're doing a string compare. You have to do a string compare with the quotes with the equal sign, because that's not a string compare. This is a string compare to equal equal. So if I do action equal equal, I don't have to put quotes around the value. Then echo running do, and then it just calls the do function. Okay? So it does that, and I have 3 different ways of doing it. This is a really short way. It's all on one line, and it's very simple. And so if it's the same thing as these, but you can just stack them up like this by using semicolons. Because semicolons are, like I can make a whole program on one line in Bash, just like I can do in C.
Don't ever do that.
Don't do it. It's really mean. Well, a lot of times you do that in inline shell scripting. When you do inline shell scripting, you're usually making shell scripts that are not this long. They're going to be like, at max, maybe 10 different like programs shifting things in and out of stuff. You're not going to be dealing with arrays and all this other stuff. I hope this presentation doesn't go a lot longer than I thought it would. All right, so we'll show the, actually I think we'll be fine. So we're going to run presentation.bash. You saw that it cleared. Remember our clear? Got it. Then it prints out, welcome to this. These are the 2 echo lines that I did. And this is the select. Okay, now the select generated all of this. I gave it the values, but it gave me all that material. If I give it more menu items, it'll actually like break it out and like give you a longer one and stuff. Yeah, that's great. You can also do this with a case statement or like read lines and different things, and I do have a little bit of that later on as well. So, that's what this provides me. Now, we'll go ahead and run this one real quick. Now this, remember I said, hey, it's going to echo out running whatever. Running do, all right? Now, from here, it's inside of the Doom function. Would you like to play it full screen or original size? Full screen or original size. And so if I hit 1, full screen. All right.
Now,
If I do 1, and I say original size. Okay. Now I've done this in a script. Now how do I do it? First, if you can see it down here, it says press return to go back to the main menu. That's also in the script. So it's come down, it's run this program. When I exited the program, I'm still inside my script. Okay. So I just hit return, well, back on my main menu. I'll show you how I did that. So, this is the function Doom video. Function Doom, so we're naming our function. Squiggly bracket at the beginning and end of every function. Here's our echoes. So we're just telling the user, hey, we're doing stuff. Here's the information you need. Read is a function. Now also, every one of these commands has a man page. All right, so just man and whatever you want, and you can learn all the information about that. So,
how come you didn't use the select menu thing? Just
yeah, I'm showing a bunch of different ways of doing something. So, there's the read manual. And read. There you go. And it's got a whole bunch of stuff on how to do it. Also, you can do read-h. Or read-help. And it gives you even different information, actually. It doesn't actually give you these as a man page, which I was pretty surprised with. But great information there. So in this guy, what I did is I said if size, well I said read-n1 size. Now what that -n1 says is read a single character and assume a return character. I could put -n2 and it would read a character, it would read another character, and then assume a return character. But if I put 1 in there and hit return, that single character would be in this variable. So -n1 size, and size is the variable. Then I say if my test sequence variable size is equal to 1. Now I also did this different so you guys can see that. -eq is a different way of saying equals. Okay, you can do, there's a whole bunch of different ways of doing all this stuff. So just so you guys know, so you're not confused when you're like, but what is this? That's different. There are different ways of doing the same things. Okay, so I say if size is equal to 1. Now this is not a string comparison, this is a number comparison. So there you go. Then run mplayer fs, which is full screen, and then the name of the file. Else, if size is equal to 2, then mplayer Doom staying alive without the fs. Okay. Let's say I didn't choose one of those options, right? Let's say I said 8. And I could probably clean that up too. You can also do a read that won't actually print the character that you push. I think that's -s, and that's really useful for like passwords. You want to make a system that takes a password from a user, does something with it, like makes a hash or something, compares that hash against a hash that you already have latently on the system to make sure that that user is authenticating with your system. You can do that. Press return to go back. Okay. So I say else. So then is for 1, or if is for 1. Else if is for 2, and then else, which is anything else. Go to this. It says you failed to enter a proper entry. Goodbye. And then that's the end of the if statement. Goodbye. Echo is press return to go back to the main menu. It just does read. So it's just looking for some input from the user, and then it sends you back to the menu because it's calling the menu function. Any questions? You guys doing okay?
Yes.
Okay. do the tux function. So tux, I made this one pretty interesting. So tux wants a fish. What do you want to give him? Flounder? Yeah, he doesn't know what a flounder is.
Oh, okay.
Tux doesn't like that. Tux wants a fish. What do you want?
Fish.
Fish. Fish. Tux happy. Okay? So that's a fun one. Now this one is a bit more complex, and I'm going to have to go down to the bottom of this program to show you some of the complexity. So, one, I left this while in here because there's actually, again, multiple ways of doing everything. This while and this while will both work. Alright? Here, I say while test, quote, because we're doing a string compare here, and again, a different way. Give is not equal, so the bang means not, in logic. So not equal to fish, do. So it's an infinite loop unless give is equal to fish. Then it pops out of the loop. Here, I did it more aggressive. I said, while true. True is always true, forever. So that is an infinite loop. But, what I said is down here in this piece of logic, break. Break breaks you out of that loop and pops you out. Okay? So, if z dash z $2, then do that. Alright? That is actually not, that needs to be a $. But apparently it's working. That's because this is going like that here. That's why it was like that. I was screwing around with this earlier. So, if not z1, what z does is it says if the variable returns nothing, then return true. So if the variable is blank or doesn't exist, then say yes, true. Here I'm saying don't do the opposite. So if it's not empty, return true. Then, so if this thing exists, I want them to do this. If it doesn't exist, I want them to do that. And so it's a little bit more complex on where you're going with this different stuff. And I'll show you at the bottom why. So, if this variable does not exist, then it will print tux wants a fish, what do you want to give him? It will read give, and then it will move on out of that loop. The reason that's there is this program has two different ways of running. We can run this program not only with the menu, but with options. Alright? So I say while getOps, HT colon. HT colon means I want it to have two variables, H and T, and T, that colon. That T colon means that it has to have a variable behind it. Okay? So I say H or T, but T has to have a variable. Then I put that into the opt variable. And I say do, so this is a while loop. And I say case, that variable, in. Now this is that case statement we were talking about earlier. Case statements allow you to say, like, here's a variable, match it with this and do whatever's underneath. Okay? So I say if the opt variable is an H, then do this. If the opt variable is a T, then do this. If the opt variable is none of those, then do that. Okay? Remember old friend exit one? So H is going to give us a helper. T is going to give tux a fish. Via passing that variable or that function a variable. And then question mark says about. So let's go ahead and try those out real quick. So if I do a dash H, there's our helping. If I do a dash off, right? So the first one is like, that's not H or F,
That's illegal.
or T. It's illegal. Cops are penalty. And if we do a dash F for fish, or no, dash T for tux, we have no bird. Says, hey, option requires an argument. We need to give it. So let's say let's clear this. Let me go back up there. And let's say we give them futon, right? Tux likes futons. No, he doesn't. All right. So I messed up the logic in there. It wasn't working before, but I want to change things. If we go back up and check that. This should work. Yeah, there you go. So I tell this variable in here, so I'm passing a variable on the command line, which is extremely useful for most of your scripting stuff. The variables are $0, 1, and so on. 0 is the name of the script. $1 is the first variable. Now in this, I'm showing you how those variables actually change numbering sequences. So we'll look at that in a second. But I passed it futon, and it says, let's give Tux a futon and see if he likes it. Tux doesn't like that. Tux wants a fish, right? If I give him a fish, let's give Tux a fish and see if he likes it. Fish, Tux happy. All right, cool. So, down here in the options, let's give Tux a number $2. Okay, now remember, 0 is the name of the program, 1 is the first option, 2 is the second one. So at this point, fish, or whatever we put in there, is the second option, because the first option is T.
So it's all delimited by spaces when you type in?
Yes. Yeah. So the first one is delimited to T. So number 1 is a T. Number 2 is whatever input you put in. Okay. And you can keep giving it options. You can start, writing poetry at the end of the script. It's just going to ignore it because I didn't call 3, 4, 5, whatever. So we saw that it wrote that. Then it says Tux number 2 or $2. What that's doing is it's passing the variable into the function. Okay, so the function actually doesn't know about these variables. If you look at the variable 1 and 2 inside of this function, it's not part of the main script. So those actually get purged, right? Not out of the program, but the function doesn't know about it. So if I try to read $2 inside of this function, inside this Tux function, it comes up as blank. There's nothing there. All right. So I have to pass that to the function. And I do that by passing it when I call the function. All right. So this is just like running another program. Right. So I'm running the Tux program. That's my function. That's the Tux program. And I'm passing it this variable. So now this variable is going to be $1. It's the first variable. You see how that goes? Yeah. Cool. All right. So if then, or if else, the else says give equals $1. All right. So we don't even want to post the user for a question because we already had that answer was passed to us on the command line. So we say give $sign is equal to $1. We're assigning the variable give, which we're using up here if we were doing it. It's the variable that it was passed on the command. Right? Then we have our if, give is equal to fish, and so on and so forth that we've gone through. No, I guess we haven't. So echo, Tux is happy. If that same, different piece of logic, then x is 0. Because we want it to break out of the program. We don't want to go back to the menu. Right? This is running non-interactive sleep one, break. Break breaks out of the while. Else, Tux doesn't like that. Sleep one, still else for the command line users. And then be done with this if statement. Then be done with this while. So this is the while here. And what we've done is called nesting. Right? So you're nesting the logic. You have this layer, then you have this layer, and this layer. And this layer is this layer inside. Well, this is a layer right there. Alright? Once it's done with the while, it says press return to go to the main menu. Waits for you to hit something return, and then it goes to the main menu. These two would immediately exit the program. Yes?
Yeah, I'm a bad guy. I want to know if I can get Tux anything other than a fish and make him happy. Can I pass break to him, or can I pass a command to him and have that run his code?
I like the way this man thinks.
I mean, not really. But if you find a flaw in how bash logic and bash programming is, which is it's pretty darn tight nowadays. It's been gone over a long time. Then you can, like, I mean, they did find an error in the system of battle, like the little 3K executable that's on everything to make the system go beat. So, I mean, is it possible? Maybe.
So, I'm talking about your code, they talk about handling user input, sanitizing user input. Is that all done like that already, or am I thinking about some other kind of program?
If you look at my thing here, mine is extremely restricted. It only has one answer.
Okay.
Else it always fails. So, if you're doing something else, and that's a good question. That's a good question, because mine is like that. It's whatever. It's printing something. It's excellent. There's nothing to do. But let's say that you had something more restricted, like you're having a program, a system program that you've written to, like you've written this program as the systems administrator. This program goes and does high-level things as root. You give it to your users, and it's set UID root, so they can run it as root, but they can't edit it or look at it. Okay, that's a great example of what you're trying to do right now. So if the person has not cased things, or just like kind of assumes, don't ever assumes that the users are going to do something some way, then it can fail. All right? That's all logic. I mean, that's all it's how you manipulate. That's how you handle the different pieces of the system. Bash itself is unlikely to break, but your code likely is.
Yeah.
That's where most of your errors are going to be. But most of your exploits are not from the coding itself. Most of your exploits are from the code.
Yeah, and I didn't think that it was. I just didn't know if that was like, I'm just doing it to put something together real quick, or if that was an acceptable way to actually handle user input.
Right, so if I go 6, it just exits. Because what it does is it follows the logic of the program. What happened is, in this program, so I hit 6 and it exits, right? And I can handle it differently if I wanted to have it handled differently.
Sorry, I hope I'm not derailing the whole thing, but I'm curious. Like, if we tried to give Tux a do,
so that thing I just did.
Function?
So what I just did, it was 6, right? So I have 5 options here. 1, 2, 3, 4, 5. All right? This select action builds that menu.
Okay.
All right? And all this select action is doing is it's taking the value and sticking it in here, right, to this variable. I handle what to do with the variable down here.
Yeah, so there's no numbers or anything. You're not
Right.
telling me.
I'm getting whatever this thing is providing me, so it's a locked in thing. But when I hit 6, this variable is blank and it keeps going. Now, if your program is poorly written and it doesn't know what to do with that, it crashes or it just sends you to a root prompt or whatever, that's where you can encounter those issues. So if I wanted to prevent somebody from, like, if I was doing like a set UID program, something like that, down here, I would have my final thing in this function be exit, like exit 0, and handle it. Or like, I don't know if select can do that, but you can say if nothing is chosen, it has to be 6, or something like that. You can do different things to try to mitigate these issues.
Does Bass have like a try-catch?
What?
Does Bass have like a try-catch feature on it?
I don't know what a try-catch feature is.
Try this and then catch the error.
Oh, I mean, we just did that in
The last example.
right here. If it's not this and it's not this, then do that.
If then,
Yeah, if then else.
else.
Else is a catch-all.
Yeah.
This is a catch-all. You can have it catch different things. It's all in how you program it. But yes, the logics do associate with catch-all or catch-some or different. Like you just have to manipulate the logic in a particular way that you want it to work. In this case, if you give it, like I gave it Bob, it read the first letter of Bob, which was B, and it said, well, that's not H or T, bye. And it gave me this.
If, then, that, and, or.
If else.
All these different commands, if, the different combinations, so the different combinations of those things.
So that was probably the most complex we're going to get in this presentation. Is there any questions on that stuff? Yes, sir.
Return values, you have return values on your functions inside the dash.
Okay. We have one. What was the question?
Okay, inside your functions,
Okay.
inside your script, you have return values.
Did you have one?
Return values.
Yes. Yes, you can say return and value and return value. You can also, I believe you can actually return variables. You can do values, variables, different things, escalate things in different directions.
A case statement where one of the options is one, return one, and option two, return two.
Yeah, there's actually a thing called return. Yes, there you go. And return. So yeah, it's return it from a function or a doc script, and it return and a method. And it will, when that function comes back, or when that program comes back, it'll return that variable to the parent process.
Are the exit values or return values were wrong?
They are,
You could log
you can log, but you have to do it. They're not in like system logs. They would be in system logs. So remember we were talking about cron earlier?
You could set it to,
Cron
right, to text
will
file.
put what the exit status is of that script that it ran. What's that?
You pipe the whole script to a text file, right? You pipe it to a text file.
Yeah, you can actually use a function called TEE. You pipe your output T, and you tell it a file. And you can actually send all of the standard out, or if you manipulate a little bit standard error, into both the file and onto standard out. So you can, there's all kinds of ways you can log things and stuff, but you generally have to write your script to handle that. The system's not just going to do it on its own. Thank you. Okay. Any other questions?
I think what the last 100 commands you put in is wrong, so you would be able to scroll back through to the commands that Michelle has executed. So for the terminal, would you be able to hit up and see the commands that Michelle has the script executed?
You can, like, you have a history.
Right.
But they're not gonna,
That's not a log.
But you can't.
Will that happen to the script or no? What happens inside the script? Will it?
No. Actually, the script is generating new. Your history is from your current session. Anything that runs inside of the script is outside of that. So let's say you wanted to be nefarious on something, right? You write a script, run the script, and then delete the script. And yeah, you can't.
You're getting your own PID when you're on this, right?
Every process on the system has its own PID. There are parents and children. When I execute this, I execute that. Now I'm currently inside of a child of the parent process. So I have my bash parent as the terminal parent. And then I ran this shell script. And so right now, I'm existing inside of the child script, right? So he's sitting there one level down.
Yeah.
Anything I do in here is isolated from the parent. And now it is
Once
running
that
through the parent,
exits,
but it's not,
it's all out of hand.
yeah. Yes.
So let's say I write a bad program and I get stuck in the program, like the infinite loop. How do I get out of that? Doing a hard
Control C.
power down. Control C.
Yeah. Control C, if that doesn't
Unless you're involved in
go to another terminal, find out the pin, kill it. If you can't kill it -9. You might have to have pseudo privileges for that, which is a more aggressive kill. There's a bunch of different ways of manipulating the processes and the process tree and the operating system. That goes for Windows and Mac and everything as well. When you get down to it, the operating systems are very, very simple. They just do the user interface very differently, and they manage some of their resources.
I see Doug just smashing his computer. I can't figure out what Tux wants.
I feel like the power button.
This is no Windows XP.
He wants a fish. Not that fish, this fish.
No flowers.
Only fish.
I'm gonna get off topic, but like today I tried to run the, I guess it's Ubuntu web browser, and it froze my computer. It was booted up. Is there any way to get like a new shell or something?
Yeah, if you're running a web browser, so you're in a web browser.
It's like no response from my mouse or keyboard anymore.
Yeah, so what you would do is you do Control at backspace, which kills X, or you could do Control F1 through F6, I think, which are your virtual terminals. Depends on the operating system, which usually F7 is an X, but sometimes some of the operating systems move that F1. So you do F2, so Control F2, and it will drop you to a terminal that's not inside of X. You find the process that's freezing your system, kill it.
So you said Control backspace kills X?
It used to. I think they've disabled that nowadays. But Control F2 will drop you into a shell. Now you don't have to log in, but then you can log in as root and kill whatever process, including X, that is messing your system up. So you go on there, you say, oh, it's Firefox, and Firefox is really just chewing on a process or something. And you go and you kill that Firefox process, and you hit Control and F7 to pop it back
Firefox,
in
you can use
X session. What's that?
To find Firefox in the pid that has Firefox has you can use top.
You can use top, but it only showed it one is at the top of the stack, being that it's using a lot of processing power. If it's frozen, it may not be using any processing power, and you might not be able to see it there. So you might want to use PS Box.
No, it's not working. Not working.
Oh, did you try? You have that going on right now?
Do Control F2. We can look at that.
Yeah, your machine might just be frozen.
My machine's frozen, yeah, so it's.
Yeah, well, I mean, sometimes the machine just can be frozen.
So that's not.
Just like any operating system will have that happen. Like it's just a hardware issue or a locking issue or it's. So.
All right, I'm sorry to distract you.
No, you're good. That's good questions. Good questions. I'm always here for fun answers and stuff. So now we're going to do bash expansion. Bash expansion is wonderful. It is so good because I use this in all kinds of scripts, all over the place. Bash expansion comes in many different forms of figures. I've only put in 3. Probably 100. There's a whole bunch of ways to do this. So here I did a series of echo statements, and I used bash expansion in 3 of them. Today's date, and I do note that it put quotes around this. So I had to escape this, and I wanted to leave that in there just so everybody would see that. If I didn't escape that, the program would crash there, being like, where's the other quote? Alright? Because that is a special character in bash. Today's date is, and I do backtick, date, backtick. Now what will happen is when this runs, it'll print today, apostrophe S, date is, and then we'll run the date command and put the output of that date command right there.
You have to do the backticks around the whole.
Yes, and the backticks are around whatever you're trying to run. So if I'm running like date minus blah, 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 or like a whole big string of stuff, I can do that inside of those backticks. And that's very, very, very easy.
So like, let's say I was like returning let's say that this data function.
Is that better?
It's data function.
Another colo palette. Date is not a function, it's a command. It's its own command. If I run date on the command line, so Control C, there, date. Alright? That's what date does. So I'm just running date, and it'll print out date. So if I go back into this and I say expansion, today's date is, and there's the output of date. So the text just runs something. So you're encapsulating something being run. It runs the program that it runs whatever you put in. So you can put inside of a script, you can put an inline script inside a text that will output a particular set of data that other script needs. So you get really deep into this. And I do this. Like I'll have like a for loop that executes a cat with an awk and some other stuff in it. And it'll basically run the cat and an awk and all that stuff, and then it takes that output and it shoves it into for, and then it does a for loop with the material that I got out of the cat and the awk and the set and all that kind of stuff.
Like if you want to do ifconfig, and then pull the IP address out of ifconfig, and then use that IP address to take action. So that would be another example where you might actually use it.
So we're in date, and that exports, it throws out the material that comes from date. Then you have brace expansion. Brace expansion says, do this, but change whatever, like print these three characters, and then print these two in the middle of those three characters, but do that for each session. So it'll say SPELL, SPILL, SPALL. And it'll make three different variables, or three different outputs with that. As you can see right here, spell, small. Like that'll work in small.
Small. And then that was real one.
Yeah. So it's like when metal, I think it's when metal is small, so it basically like heats up and shears. Yeah, you got a lot of spalling inside of your engine. It's not going to be good. Let's take an angle right with that. All right, and then the last one is we're going to use bash expansion to list a significant count of numbers without effort. Now we did this in one of the FSCJ ones, where basically we say we want 1,000 values, we want 10,000 values, we want 100,000 values. Let's do that. Oh, there you go, done. I don't have to sit there like 1, 2, 3, whatever.
Use that in map scan.
Yeah, you could. That's perfect example. I want
168 bracket.
right. I want these values from, I want 192.168, 100 through 250, and I really don't want to type all of that. Boom, done. And so remember I said 3 through 50, and so it says 3 through 50 with a space in between each one. You can also do different things to actually like exclude things. So you can say 3 through 25, and then 27 through 50, and you can do exclusions. You can actually, I believe you can have it like hot numbers, so you can do like every 2, every 4, every 3, whatever, and just do that. So that's bash expansion. Any questions on bash expansion? Right. And then we have arrays. So arrays, you put things in arrays and then talk about it well. Arrays are fantastically useful in bash programming when you're dealing with data. Alright? I built an array. I builds an array called foo. And I say bottom. Okay. And so what I did is I said, I want to see all of the variables in that array. So I echo $, squirrely bracket, foo, square bracket, star, square bracket, squirrely. Squirrely bracket says, I don't want just foo, because it'll just read foo. I don't want just foo. I want this entire thing as the variable. All right. Now that's very useful. There's two ways of defining variables or calling variables, and that's just the $sign and putting the variable name, or the $sign and the squiggly brackets around the variable name. Most of the time, just putting the $sign and the variable name is okay, but you're relying on Bash's ability to interpret the code and say, oh, you meant this. Okay? When you put the squiggly brackets, you're saying, this is what I mean. This is the variable. Okay? Now, it's required in this particular case because it's just going to say, oh, the variable is foo. It doesn't really interpret the rest of it. So I say foo, bob, trump. Now, these things start at 0, like pretty much everything else in Unix. So this is variable 0, this is variable 1, this is variable 2. Here, I say, I want to pull just the middle variable. I can say echo foo 1. Right? So this is the star, echo foo star, bob, trump, echo foo 1, your, it's the middle variable. And then, if I want to change a variable, I just rewrite the variable. Like there's nothing real special in changing variables in this, so I just say foo 1 equals my. So I give it the string my, it's like, that's that array, count 1, is now mine. And then I echo foo star again. Now I've got Bob's map. I just changed that one piece of that variable, that array variable. All right. But I have just one more thing to show you guys. Any questions on arrays? The arrays, again, can get very complex. You can have multi-dimensional arrays. You can do all kinds of crazy stuff. This is a very simple show on like what you can kind of do. Again, we have our press return to go back to that menu, read menu. This is the this is what's inherent of the script. Okay? So all the stuff above this, except for the check to see if it's UID 0, is in functions. You have to put functions before you put the rest of the material because it has to read the functions and put those in a memory. Be like, okay, this is a function, put it in memory. This is a function, put it in memory. Before you call them. If you call them before you define them, you're gonna have a bad time. Alright, so here's our GitOps. So this is our handling of what's on the command line, if there is anything. And this is the thing that runs the whole program. Menu. It just calls that function menu way at the top. It says, hey, run that. And then inside a menu, it goes and talks to other things, and goes talk to other things, then relink back to menu and everything. And that's the whole program.
What is that, ESAC doing?
Escape.
It's case spelled backwards, it's the end of the case.
Oh, shit.
Just like F-I-N.
I actually didn't get that. I always thought it was escape, but no, it's you're right.
It's
Escape.
backwards, it's in the case.
Yeah, that's what I thought.
What is foo and why do I see it everywhere?
What's that?
What is foo and why do I see it everywhere?
It's probably from it's probably from the military. It's foo bar. They just separate it as foo and bar. They're very common things. Now, you have to also understand that computers originated a lot from the military.
Yeah.
So your internet stuff, your major computer infrastructures, all the different stuff was mostly for defense. So like anti-nuke defense and also the aim guns from bombing ships inland and stuff like that. All you need all the computers. And so you see stuff like that, FUBAR being an acronym I probably shouldn't say on.
Messed up beyond our
Yeah. And some of the things that you see in Unix come from like Berkeley. So Berkeley was a school, and there were people that were dropping acid and stuff. They're like, oh, let's make some fun stuff. So there's demons and parents and children and zombies and all kinds of crazy
There
stuff.
you go. This is the best definition ever. Food is a mystical substance of the computing world. Food makes all programs work and is offset by its counterpart water. Food law is the yin-yang of the computing world. So seriously, food is a term used for a sample variable intended to indicate that it has no particular meaning, not a syntactic variable.
Yeah, I heard you say it before, and then I saw it in the it's on the man page for zip. They zip out food.zip.
Yeah, it's a placeholder.
Yeah, it's
It's just a placeholder. It's a simple variable that everybody just kind of uses. That's all it is. Did you have a question in the back?
So if I'm trying to return,
You see that?
if I'm trying to return a value from a function, how would that exactly,
You would probably use return, but I'd have to go and research that. It's not very often that I've done that. I've done it like once. You can return values using return. You can write things out to like files and then reread those files if you wanted to. So you can manipulate, like use one function and manipulate data in one way, and use a different function and do it in a different way, and always use the same file and stuff like that. TLDP. One thing, I don't know if I iterated well enough. Give here and give here. When you're defining it, when you're calling the value. The dollar sign says I would like to request the value of it. Without the dollar sign, you're assigning the value. Okay, so if you look down in our function arrays, when I'm assigning it, it doesn't have a dollar sign. When I'm requesting, it does. So assign, request, request, assign, request. And I don't know if I pointed that out. That's very important to know. Yes.
You mentioned passing options to the command line. They're actually called arguments.
That's
Passing
right.
Arguments to the command line.
Right. No, I was thinking of
First argument,
kiddos, but
yeah.
arguments.
Your first argument, second argument.
Yeah, these are arguments. Okay, consider it there. While GitOps HT, you're receiving arguments from the command line. And $0, $0, $1, $2, those things, those are arguments to the program.
Second.
He's got it.
One more. If you go back to your code on Tux, you were just there. Yeah, you give. Read, give. So you were asking about exploitations. That would be probably the one place in this code that I could say you probably exploit there if you were to buffer overflow the read. That's about the only
Directories.
But that's again from bash, so you're going to exploit bash, not necessarily.
That's the only place I can see right now.
That would be a good place to try, and that would be trying to exploit bash and see if it's because you're not exploiting the code, you're exploiting it not being limited. So the way I could limit it is I could say read -n 50. Okay, so yeah, as soon as you hit, like, you're probably going to hit 10 and hit enter, right? But if you do 50 characters, it's going to hit enter 40.
Wouldn't that be a good way to do a directory reversal attack?
I don't know.
You know what that is? It's where you force it to switch directories so fast that it causes the system to crash.
It's not switching any directory.
You can't get out of the script to
You
the
do it to a shell.
Yeah, but you don't have a shell, you have a script.
Yeah.
Right, script is just shell commands.
You're inside of a program.
Yeah, you're inside of-
You're only allowed to do what the program tells you to do.
You don't have a shell.
Yeah, you can't write
The goal would be
printf
to
and
get
it
that,
does something.
but
Bash is a shell script.
well, Python is a
shell
interpreter.
commands.
I mean, I can.
But it's just running shell
Python.
commands, right?
What's
So
that?
why, we just run a shell command, so why couldn't I put in dir, directory I want, Python,
Okay,
directory
so-
I want?
Let's do that. So let's say I do this, -t, fish, right? It's giving Tux a fish. It's an open-ended thing. I can type stuff in there.
Oh, I'm not saying just in the Tux command. saying just in general, you can use the shell script, because he was asking whether you can use shell script as
So-
a point for it. I said you can use it for a directory traversal attack.
A shell script, yes. This shell script.
Yeah, not this one, I'm just saying in general, because you were asking.
Oh, yeah.
about this exploit.
Oh, okay, if you could do an attack with a shell script.
The problem is that his script is not executing
Right.
what you're
It's
putting
not-
in, it's
You could
looking at what
use-
you're putting in and executing something based on that.
Okay.
You would probably not be able to use this script. I'm not gonna say you can't, but
Yeah,
you
you can
probably
use it
can't
back.
use this script to manipulate the system. If you're
So,
running-
okay, so maybe, I think Mike cleared it up for me.
Yeah.
If your menu says, pick one of these items, it prints the items to the line, and then it takes your input and runs the function that you call, that would be something that you could export, right?
Right.
So if I have to type Doom in order to run the Doom function,
No,
then I
and
might be able to
understand
call other functions that are
Yeah,
not.
Yeah,
well, if
so
it ran
you
it
know,
directly
all
from the
functions
command,
are not listed in that.
Okay.
They're not listed and not intended for you to run, but you're still not running a bash script.
Yeah.
So you're limited to what you have. Now,
But
what you
that
could
would
try and
be
do
for
is,
those functions exploits.
right, what you could do is try and get it to, like, let's say you're reading, you're reading the input to a variable, and then try and do something. Well, if you could somehow trick his code to think the variable has ended, but yet you put a code after it, then you could. But let's say, if this variable, if this thing equals 1, well, if the variable could be 5 in quote, that kind of thing, and then where the variable becomes now in quote kill, it would then see, what would be end up being run is quote in quote, kill, and then you could do that, right?
That would be like forward action.
Right. I mean, to you, a traversal attack would be, so here's the deal with a traversal attack. If you were somehow asking for a picture to show, and you were asking the user to give me a location of a picture, intending that the user would pick from all the pictures in their pictures folder.
But instead they type in just a random command, delete something.
Like
This
Doom
one is executing this now. If I had done this in a different way, if I had said, hey user,
Give me a video.
give me the video you'd like to play. This command, this script is executing a command on the command line here. And what I can do is if this is a variable, then what I can possibly do is go and say, like, throw in an execution string.
Yeah.
Right. So I could say, tick, execution, whatever, tick, and so it would run the player, and then before player ran it would run whatever you did there. So that would be a bad coding thing, but it's sensible, that's why you might try to do that.
Yeah.
And so,
You still have to get past the security. If you run this as a user, it's not going to bring you any conditions. You have to do it.
Yeah, that
right, well, this particular script, you're running as the user that is running the script in.
Depends on what I run, because if I run a reverse shell back with my photo, we'll listen and then have a shell on your computer, and then do other things.
Right.
You're right.
Generally, you don't want to expose bash shell scripts to the web or anything like that. They're more for doing systems administration level things or doing neat things on your system. They're not for exposing to the internet and serving up stuff. Now that's where you get the whole of PHP and CGI. Both of those are scripting, and they both have big problems. And they can both do really bad things. So it's really important to keep those systems up to date and make sure that your the thing like if you're running PHP or something like that, make sure it's running okay. Make sure it's up to date.
Make sure it's running SE Linux.
SE Linux is a fantastic way to harden your system.
Sorry to hijack what you're talking about. I've just heard people talk about treating variables as, a certain way. And so now
Right.
you and Mike have kind of.
No, this is
what
all
that means.
interesting conversation.
The bit-
I imagine everyone people are getting good info out of that.
The biggest thing you have with inputs is input sanitization. So if you're doing anything more than this, right, you want to make sure that the user can't input something that could be variable, right? The whole body tables, XKCD
Yeah.
gag is common because of the fact that this person in this comic was able to input into the name field of a system they ended the SQL command and then put in drop the whole database. So by putting in exposing an input field, they're able to get this whole database deleted because the input field didn't
I love that comment.
But so with this kind of script, it doesn't have that because instead of open-ended, you're just asking for, is it one of these 5 things? If not, then fail.
What you're talking about, I'm sure, is the one, the comic on somebody exploiting XKCD.
Right.
Yeah. So what he has said is basically.
Well, that's very meta. Exploiting XKCD, sorry.
Yeah. So, yeah. But, so what XKCD had done in the comic, it was pretty funny. It was basically well, it's for the people that didn't talk about, but those license plate readers and the things that'll read things on cars, the automatic things. Well, they had suggested in a comic that you just put like drop all tables over your license plate. So as soon as something reads it, if it's got an exploit, it just reads it, executes it, drops everything in the database. Without even having to be there. Because that's crazy stuff going on. So, you had a question.
Now, can you put backticks or think backticks?
Yes, but they don't execute at the same time. So, if you wanted to SSH to a box and then execute something there that had backticks, that'd be a good example. Then you would put backticks around the SSH command. And then inside of that SSH command, you delimit them. So you put your backslash in front of them. And what that does is it tells whenever the thing that's running immediately reads that, it will ignore those, remove the backticks, and send the output to wherever. Okay, so you can actually layer those in. And you don't usually see that with backticks. You see that a lot more often with quotes. You'll have nested quotes sections. So you have quotes, and then you'll have to have backslashes in front of other quotes because you're quoting one thing or you're quoting another thing. And there's 2 different types of quotes. The double quotes interpret things that are inside of them. Single quotes do not. And so you can pass things back and forth using the different types of quotes. So you say single quote, some big string with double quotes and like all kinds of special stuff. Like you don't want the current session to interpret, but you're putting it inside a single quote, so it just sends it along. And it's just like, okay, here you go, top of it. And then inside of that, you have double quotes. And so when it gets to the next place, it hits those double quotes and says, oh, I need to interpret this. And that next layer down, you try to interpret this.
How do pipes work?
What's that?
Pipes.
Oh, pipes.
Ooh.
What about pipes?
They get water.
How do they work?
Well, pipes send standard out to standard in for the next perfect. So if I do cat file, pipe, grep, food, all right? What it's going to do is it's going to cat file. As it cats that file, it's going to send the standard out, what would usually go to your screen, to grep. Grep would take that on standard in, and then run your grep food against the standard in. So it would just basically be reading what supposedly you're typing to it. And it reads that and then exports that to standard out, which if there's nothing else in the pipe, then it would just export it to your screen. So there's three human interface buffers. There's standard in, standard out, and standard error. Okay? Standard out, standard error, output material. Standard in, input to whatever program you're interfacing. And you manipulate that on the command line using your pipe, your greater than, your less than, your greater than, your less than, all kinds of things.
Standard error is all your exit.
Standard error is the second buffer. So if you ever see something where they say, hey, do 2, I think it's like 2 ampersand redirect 1. What that is it is sending the standard error material into the standard in buffer, or the standard out buffer. And the reason you would want to do that is if you're capturing the standard out buffer, you want to be able to capture the standard error buffer too. So then you have the entire output. Because if it's still output to your console, but it wouldn't output to, say, a log. So you do that to redirect all that output into the buffer that you want, and then you redirect the buffer into the right. So
I use the cat command to examine the contents of files, but I heard that's not the right way to do it. What is the right way?
the cat command to what?
Like if I want to see what's in the files, the cat files, right?
That's fine. It shows you the whole thing. There's generally it's going to be cat more and less. Yeah, just remember that less is more. To make it nice and confusing. Okay? So cat is actually the concatenate command. It's actually supposed to be used to take multiple files and stick them together. One of the main reasons for it exists. Now it's extremely useful whenever they use it or to dump the contents of the file onto the stand out. Okay? So that's what cats more is it's kind of like the cat output, but it does it in pages. And it has a couple other little functions. I think it has search and some other things, but you do more in the file. And then you get the first page of the file, you hit space, and you get the next page of the file. You hit space, and you get the next page of the file. Less is more. And the reason they say that is because it's more useful to them. Okay? So more just literally just, here's more. You can't go back up the file. All right? Less, you go up and down. Less is kind of like view, which is the VI.
Which is kind of like.
Well, view is VI without editing. So it's view is read only VI on a file.
Is it also as hard to exit as VI is?
It is view.
Okay.
You just think right. But yes, there's lots of programs, and that's why the learning curve on Linux is a little steep at the beginning. But once you get past that, we're like, okay, I understand what programs are doing what. It starts getting easier where you start like, okay, I can use this, and you use that, and somebody says, oh, this program's better. You're like, whoa, that's really a lot better. I'm going to use that one instead. And then you change what you're using. You know, eventually you start like, oh, I want to use this one for this, and that one for that, whatever.
Why do you use VI?
That's one of the things that I learned most in the beginning.
It's been around the longest.
Didn't fight more.
I don't think that it has, but I learned VI because when I was in college, I was working with one of my coworkers in the theater. He always used VI, and I tried out Nano, and Nano was okay, but VI at the time, this is early 2000. At the time, VI had a lot more features than Nano did. Now, Nano nowadays has a lot more things like syntax highlighting and different things that it didn't used to have. And so when I learned VI, it was because it was a superior tool.
It's about that leaf pad, bro.
The first job that I had, we were in Unix. Unix didn't have Nano at all. You had VI, and it didn't have Vim either. You had VI. I think you had Emacs too. I've gotten into Emacs accidentally a couple of times. I'm like, oh my god, what happened? I don't know what's going on, and I can't. And I end up having like background the process and kill it because I'm like, I don't know how to get out of this because I've never learned it because I don't care. But some people might be like that for VI. Now,
Wow.
in Linux, Linux and systems administration, you really need to know an editor. And preferably an editor that is ubiquitous. VI is about as ubiquitous as it comes. There are systems that don't have it. There are systems that don't have Unix. Pretty much everything has it. So, and a good argument for learning VI, if you're becoming a systems administrator, is that it will be everything on every system.
So Nano was released in 2000.
Well, that would be why it didn't have the feature.
But
Or using the right way to do it.
when do you think VI was released?
I'm going to say 73.
No. And no. 76.
Hey, I was close. And I didn't overshoot. Does that mean I won?
You did it. You
You
did.
said
To be
73.
correct.
76.
Congratulations.
73.
Alright, I guess if I'm looking down. So you overshot the number of years ago it was?
No, that's not how.
1901. Okay, so you win. Like, yeah.
One guy. You're that guy.
$2.
Yeah, oh, you're that guy too. All right, so are there any other questions before we do Lush? Are we doing Lush here?
Well, he's
No,
toxically
it's
sick.
contaminated.
This has been
Okay.
confirmed that we're not gonna go, so as some of you may know, there's a member of the LUG who lives in the building now.
I'm gonna go ahead and.
But him and his girlfriend are quite sick right now, so we should not go up there.